Out beyond Jupiter lies Saturn, a planet circled by multiple moons and rings. It's like a miniature solar system.
Imagine having a mission with the power, the instruments, the capability to explore all aspects of the Saturn system.
That mission was Cassini. It would become our eyes and ears in the Saturnian system for over 13 years. But by September 2017, Cassini is almost out of fuel.
Cassini has been orbiting Saturn and studying the Saturn system for over a decade. End the mission. We're going to lose control soon. So rather than let it just go derelict, we headed into Saturn. Go out with a bang.
The Cassini team goes for broke. They program the probe to head straight for the planet.
How cool is it to sort of sacrifice everything you've got to sort of learn your last bit of information and then crash and burn?
We are in the atmosphere.
As Cassini was careening toward its death, it still had instruments that continued to work, and as each instrument died, there was still a set sending back data and information.
Cassini wasn't designed to plunge through Saturn's atmosphere. No one knew how long it would last before burning up.
I remember sitting in a room with my colleagues on Cassini and watching that radio signal, that sharp green peak that told us Cassini was still linked to the Earth.
We could monitor the atmosphere as we flew into it, and right up until the last, it was sending back signs.
I was really impressed by how long Cassini lasted in the Saturn atmosphere. I mean, go NASA engineering.
As Cassini plummeted down at 77,000 miles an hour, it was bombarded by gas molecules in Saturn's atmosphere. Friction started tearing Cassini apart as it struggled to maintain contact.
As the antenna turned away, we actually saw a secondary little peak, and we thought, okay, Cassini, hang in there, keep fighting. And then just that green flat line.
Just heard the signal from the spacecraft is gone, and in the next 45 seconds, so will be the spacecraft.
Cassini's heartbeat was gone, and we knew the mission had ended.
It just vaporized in the Saturnian atmosphere, and so it has become a part of Saturn itself.
Cassini's death plunge was the last of a series of daring dives.
Prior to ending Cassini's mission by sending it into Saturn's atmosphere, NASA's engineers and scientists came up with an idea. Let's do dives into the region between the tops of Saturn's clouds and the innermost area of Saturn's rings.
Beginning in April of 2017, Cassini ventured between Saturn and its rings 22 times. Scientists called it the grand finale.
On these dives, Cassini got closer to Saturn's cloud tops than any spacecraft ever had before.
Saturn is an enormous ball of hydrogen and helium, a gas giant.
Fundamentally, it's a really very different kind of planet than we're used to in our everyday lives.
Cassini snaps close-ups of the planet's gaseous surface. The pictures reveal a turbulent and stormy world.
We think of some storms on Earth as being particularly violent. If you've ever been in a hurricane, that's not a fun place to be. But the storms on Saturn, the wind patterns on Saturn can make that look like a mere breeze in comparison.
On Saturn, one storm stands out. Its location is marked by a distinct shape.
One of the really weird things is that once the bands go around Saturn, They're all circular until you get to the pole. And then there's a hexagonal band up there. No one expected that.
During its lifetime, Cassini took multiple images of the hexagon.
Whenever we posted an image of the hexagon, the hits to the website went through the roof. I think people thought it was so mysterious.
When I first saw this, I was blown away. I mean, who could imagine having something this regular, almost geometric, on the atmosphere of a planet? It's really just phenomenal.
In 2018, Cassini data reveals this hexagonal storm could be a towering structure hundreds of miles in height.
It's this gigantic structure. It's many thousands of miles across, and right in the center, right at the pole, is this sort of permanent vortex, a permanent hurricane. So it's kind of a creepy eye-like thing staring back at us.
Each side of the hexagon is as wide as the Earth.
It seems artificial. How do you get a hexagon-shaped storm or cloud structure on Saturn?
Scientists think that Saturn's spin interacts with air currents to create this symmetrical shape. But they don't know why it's lasted for decades.
That's the puzzle. How can you get a six-sided jet stream that's stable for so long?
But while the hexagon shape is stable, the color has altered. Over 4 years, it changed from mostly blue to golden brown. The transformation is linked to Saturn's seasons.
The seasons on Saturn are caused by the same thing on Earth. It's the tilt of the planet. And so as Saturn is going around the sun and its north pole is tipping toward the sun, you start to get more light up there.
This sunlight interacts with the atmosphere, producing suspended particles called aerosols.
It actually looks a lot like smog. It turns things more orange. So over time, the hexagon went from blue to orange.
The color change happened during one of Saturn's northern hemisphere's summers. But mysteriously, the very center of the hexagon remained blue.
Now, this could have been for two reasons. Maybe the haze never formed in the eye because the eye was shielded from the sun, and the sun is responsible for creating the brownish haze that we see on Saturn. Another reason is maybe the actual vortex is sucking the haze down. Maybe there's something like the eye of a hurricane. There's haze that forms over it, but it gets sucked down into the eye.
But the storms on Saturn aren't the only extraordinary thing about the weather. When Cassini dives through the rings, it discovers rain. Rain falling onto the planet from space.